Today I'll explain how discrete symmetry reduces evolution operators into evolution on elementary cell. We already saw one example. We saw it for translations when we were discussing diffusion on regular lattices. And I don't know which one is easy to understand. Today I'll do it on finite rather than infinite group, discrete group. Both of them are very frequent in physics. My exposition will proceed in two parts. The first part will be very easy to understand. The space is partitioned or tiled. Whenever there's discrete symmetry, it's tiled by copies of fundamental domain, just like this floor is tiled by square tiles. We can use this to replace the functions by vectors of functions, each one of them defined on a separate tile, each component of the vector, and then the evolution operator becomes a vector on the space of tiles. That's how finite group comes in. And invariance can be used to reduce it to a very elegant form. So action is group action, which is some simple finite matrix, subgroup of permutation group, times evolution that only happens on the domain itself, fundamental domain. That'll be step one. Step two, I don't see any way you can possibly understand without much extra reading. I'll have to use group orthonormality theorem. I see no way to derive this in few lectures in this course. Here is our state space. And for lack of imagination, it's a high-dimensional space usually, but for lack of imagination, I can only draw something that looks like a plane in 2 dimensions. If there is a discrete tiling by a symmetry group, then what happens to this state space, it gets tiled by a fundamental domain. And we pick one tile as a fundamental tile.